Preparing videos for communicating activities efficiently requires much effort, whether it be in research, sports, or surgery. Particularly in the field of surgery, time is a valuable resource. A surgeon's schedule is filled with daily activities, including discussing cases with colleagues, making rounds, patient consultations, and of course, operating on patients. Despite their task schedule, surgeons carve out time to record videos of their surgeries and create summaries. My name is Ignacio Avelino, and in this video I will talk about why surgeons summarize videos, how they do it, and how they collaborate to divide the workload. Trigger warning. This presentation includes videos of actual surgery. We applied a filter to the videos to reduce their visual impact, and we will show a warning in advance like the one you see at the bottom of the screen. Video is at the center of minimally invasive surgery. Surgeons insert an endoscope, a camera, into a patient, along with tools they manipulate while looking at the endoscopic video on a monitor. Recording the activity is straightforward, as surgeons simply need to record the endoscopic video. However, finding relevant moments for communicating the activity is inefficient, as surgeons need to seek through a great deal of routine activities. Therefore, surgeons summarize their videos, condensing the important moments in 5 to 10 minutes of footage. Now, although there are automatic approaches for summarizing videos that make use of features such as audio level, changes in scene angle, colors, and motion, these are not adequate because surgical videos do not typically include audio, they are fundamentally a single long shot that lasts for hours, and the colors are rather uniform. Therefore, surgeons manually summarize videos, but as this requires much time, they summarize fewer videos than they would like to. To inquire about surgeons' practices surrounding video, we conducted semi-structured interviews, we observed surgeries, we observed how surgeons summarize video, and we carried out a survey to validate our findings. The results show, first, how surgeons use summarized videos, which highlights their importance. Second, how surgeons summarize videos, which highlights the high cost the process incurs. And third, how surgeons collaborate to summarize videos. Let's look at this in detail. We identify 6 uses of summarized videos. The first use is to improve one's own practice. Surgeons review video summaries of past surgeries as part of their preparation routine before performing an unusual surgery. The second use is for education. Participants reported using videos to teach strategies, show different ways to perform a particular gesture, including what to avoid, or to illustrate complications that can be used to trace mistakes. The third use is for discussing cases. Videos can objectively convey the extent of diseases, like cancer, when presenting their severity. This can make them more appropriate than other materials, such as subjective scores, for making decisions. Videos can also be used for scientific conferences and studies. Conference calls can have a specific focus for videos, which include rare procedures, particular anatomies, rare complications, or even compilations of a surgeon's worst moments. The fifth use is for communicating with the public, such as patients or wider audiences. Lastly, for keeping legal traces of their surgeries. In our follow-up survey, 31 participants rated the usefulness of each of the 6 cases on a 7-point scale. Most survey respondents agree that education and scientific publications are the most useful ones. The diversity of uses reflects that videos are an important tool for surgeons. But what is the cost to produce these videos? When we asked how much time it takes to summarize a video with respect to its duration, respondents indicated that it almost always demands more time than the surgery itself, even up to 6 times. This leads us to our second main finding: how surgeons summarize videos. In our study, participants started with the full video and iteratively removed video sequences until reaching a desired length. We formalized this process in 5 steps. The first is overviewing, seeking through the full video to get a sense of the surgery. Then, cleaning, which consists of removing irrelevant segments where nothing useful is visible, like when the endoscope lens is dirty or outside the patient. The third step is course sequencing, where surgeons identify the broad strokes of surgery, which usually correspond to the procedure stages. Then, fine sequencing, where surgeons trim long sequences that show multiple repetitions of the same gesture, selecting one execution that best exemplifies it. And finally, contracting, which consists of removing uninformative frames that are considered lost time within a sequence to show only the beginning and the end of the process. These steps tell a story of why the extensive time devoted to summarization is not a conscious choice, but rather the result of inadequate technological support. Now, one shortcoming is that consumer video editing tools impose a working paradigm, as they require users to remove video segments. However, participants repeatedly show their intention to retain segments. Thus, we posit that summarization would consume significantly less time if tools would support selecting sequences to keep instead of those to remove. The other shortcoming is that video editing tools come into action after video is recorded, and the semantic information that arises during surgery is not captured. To explore the utility of this information, we encourage participants during our second round of surgery observations to indicate key moments that could be relevant for summarizing the video. Participants show great interest in capturing moments that relate to the surgical steps, the patient anatomy, particular surgical gestures, and unexpected or critical moments. Our third and last main finding relates to the collaborative facet of the summarization process. Participants perform video summarization together with colleagues, mainly for efficiency, of course to divide the time-consuming task. This collaboration happens asynchronously, as one person starts the process and hands off an unfinished summarization project to another person. A common task division we observed was surgeons first delegating the initial steps of cleaning and course sequencing to a resident, who produces a shorter video so that the surgeon can then perform the steps of fine sequencing and contracting. To collaborate, participants did not rely on functionalities within video editing tools simply because they do not exist. Instead, they developed ad hoc coordination strategies, aiming to make knowledge persistent as a form of articulation work. We identify three strategies. The first is segmenting the live recording during surgery. In our study, some surgeons asked a nurse to stop and restart the recording by pushing the record button. This strategy can serve two purposes, either excluding sequences that surgeons know are not interesting, or creating multiple files to be used as navigational landmarks during summarization. The second ad hoc coordination strategy is to capture moments on external media, for example, taking pictures with a mobile phone as a reminder of events to keep in the summary. The third strategy takes place after surgery, when summarizing video. It consists of engraving marks on partial video summaries to either signal that a sequence is important or to coordinate the process. For instance, that a sequence is finished and that the next one needs editing. These ad hoc coordination strategies have their own drawbacks, as stopping the recording can lead to the loss of important moments, and marks such as gaps in the video, photos on external media, or title cards in the summary not only require scanning the full video to find them, but most importantly, they do not carry semantic meaning, making it difficult to use them for coordination. Now, before wrapping up the talk, I want to emphasize a key takeaway. Consumer video editing tools do not support the articulation work that is needed to coordinate interdependent tasks. This leads to breakdowns in coordination, specifically in the division of tasks and assignments, who does which step, and in the management of dependencies. Is this step done so that I can start the next one? We posit that two key aspects are missing. First, enable the capture of information during the data generation stage and transferring it to the data processing stage. Commercial cameras such as the GoPro have started to implement functions to leave marks on video while they are recorded. This is only a first step, as we need mechanisms to include a layer of semantic information that gives meaning to the marks. Second, making the common field object, in our case the video itself, also a coordination artifact. Remember that a coordination artifact is a symbolic object used for coordinating actions. For example, a shared checklist, where as multiple people check off items when they complete them, they can coordinate action. One way to make the common field object a coordination artifact is to use the same layer of semantic information to render explicit protocols, conventions, and the state of the process. In our case, this would mean coupling the video footage with information about which segments need to be kept, who should perform the different steps, or which segments need revision. Now, to wrap up, let's go back to summarization itself. Throughout our study, surgeons expressed their desire for automatic methods, but these are unlikely to achieve the desired outcome, as nuances like the purpose of the video or the intention of what to communicate are difficult to model. We believe that a compromise between automatic and manual methods is a much more promising approach. Surgeons would capture semantic information during surgery, that a system uses to work on the different summarization steps, proposing paths, alternatives, which then the surgeon can work with. That is all for the talk. On behalf of my colleagues, thank you for listening, and please do reach out to us with your thoughts. And of course, we hope to see you at CSTW.